Good morning, students. Today we are going to discuss about Newton's first law of motion. As you can see, the statement of Newton's first law of motion, it states that if a body is in a state of rest, it will remain in the state of rest, and if it is in the state of motion, it will remain moving in the same direction with the same speed unless an external force is applied on it. Now, what does the statement means? That if a body is moving, it will continue to move with the same speed in the same direction until and unless you apply some external force to stop it or to change its direction or to reduce the effects of its motion. And the other part is, if the body is in the state of motion, it will remain in the state of motion until and unless again an external force is applied on it so that the motion stops. So that is the statement of Newton's first law of motion. Now coming to the next part of it is inertia. What is inertia? It is the property of an object by virtue of which it neither changes its state nor it tends to change the state is called inertia. Now what is state? It is state of rest or state of motion. So if it is in the state of rest, it will neither change its state of rest, or if it is in the state of motion, it will neither change its state of motion. It will remain as it was. So coming to the next part, that is relationship between mass and inertia. It is very simple that more the mass, more is the inertia. That means, suppose you have a tennis ball and a cricket ball. I am talking about a deuce ball. Okay. So tennis ball is a canvas ball and cricket ball is a deuce ball. Obviously, the cricket ball has more mass than a tennis ball. So if you apply same force on both the balls, you will find that the tennis ball moves with a greater velocity than the cricket ball. Why? Because the mass of the cricket ball is more than that of the tennis ball. Similarly, if both the balls are moving with the same velocity, you want to stop both the balls. So you will have to apply more force in case of the tennis ball than you have to apply in case of the cricket ball than you have to apply in case of the tennis ball. So more the mass, more force is required even to stop its motion. So now we have seen that more the mass, more is the inertia. Okay. Now we will go to the next part, that is kinds of inertia. There are two kinds of inertia. Now you see, we have come to the two kinds of inertia. One is inertia of rest and the other is inertia of motion. Now what is inertia of rest? The property of a body by virtue of which it will try to remain in its state of rest if it is at rest is called inertia of rest. And what is inertia of motion? The property by virtue of which a body will remain in its state of motion until and unless an external force is applied is inertia of motion. So now we are going to discuss some of the examples for inertia of rest and also for inertia of motion. Now first I will discuss two examples, which the first part will be for inertia of rest and the second part will be for inertia of motion. I will take a very common example. Suppose we are traveling in a car or in a bus. We are at rest, bus is at rest, we are sitting inside the bus, we are at rest. Now suddenly the bus starts. what will we do? We will have a tendency to move backward. Now, why is that so? It is because of inertia of rest. How? Just pay attention. See, when we were sitting inside the bus or the car was at rest and we were also at rest. So, our lower portion of the body was in contact with the bus or the car. Now, when the car started, then the car began its motion. The lower part of the body, which is in contact with the car, that also started to move. But the upper portion of the body will have its tendency to remain in the state of rest as it was before, due to inertia of rest. And so, the upper portion of the body will have a tendency to remain in that state. So, the car moves and we fall backward. So, this is the best example of inertia of rest. Now, the second part. With the same vehicle, we are moving. After some time, our upper portion of the body also shares the motion as that of the car. So, the whole portion of the body is in motion. Now, after some time, the car applies the brakes for stopping. So, what happens? Our whole body is in motion with the car. When the car applies the brakes, the car comes to a stop and the lower part of our body also comes to a stop, but not the upper portion of our body. So, it is moving along with the car. So, the car has come to a stop, not the upper portion. So, the upper portion of the body will have a tendency to lean forward. So, why it is moving forward? Because it was previously in motion due to inertia of motion. When the car applied the brakes, we have a tendency to move forward. Is that clear? So, that is inertia of rest and inertia of motion. There are other examples of inertia of rest. One example I am telling. Suppose you have seen in your house that your carpet which is there or some cloth which has become dirty. Your parents or the maid servant, whoever comes for cleaning the house, just give a jerk like this. Now, what happens by giving a jerk? The dust particles which are clinging to the cloth, they are at inertia of rest along with the cloth. Now, when we jerk the cloth, we bring the cloth in motion, but the dust particles will still remain in its state of rest due to inertia of rest. And so, you have moved the cloth, but not the dust particles. So, as the cloth moves away, the dust particles, because of its inertia of rest, it falls down or it settles down. This is one example of inertia of rest. Another example is that you have seen certain trees which are bearing fruits, small height, not bigger height, you cannot do in the bigger trees. So you jerk the branches. What happens? The fruits fall. Why it is falling? Previously, the tree is at rest, fruits was at rest also. So when you have given the jerk to the branches came into the motion, but not the fruits. So the fruits, due to inertia of rest, falls down. It happens to the same with flowers also. If you give a jar, the flowers falls down. There are various other examples which you will find in the book. Now let us come to inertia of motion. As I have given you one example that when the brakes are applied in the car stops and we have a tendency to lean forward. You have often seen when an athlete takes a long jump, what happens? He runs before taking a long jump. Why is he running before taking a long jump? He can jump by standing also, but he is running before taking the long jump so that he can go through a larger distance. That means he can travel a larger distance by running. Why is this happening? Because when he started running from a certain distance, he gained inertia of motion. His body has come into motion. So when he started jumping or when he started the jump, he can travel a farther distance because he has the inertia of motion with him. While standing, he can jump up to a smaller distance. But when he runs and jumps, he can travel a much larger distance. Clear? Another example of inertia of motion, very common thing, which at your age we all have a tendency of coming out of a running bus. Before the bus stops, you try to jump out of the bus. What happens at that time? When you jump out of the bus, you will have a tendency to lean forward. Why is this happening? It is happening because when you are jumping out of the bus, then your feet strike or comes on the road. Your feet comes to rest. But the upper portion of your body is still in motion. So when you jump, your feet comes to rest, but not the upper portion of the body. So if you try to stop at that moment, you will fall in the direction of motion of the bus. That is why if you come out of the running bus, you should run along with the bus through a certain distance and then stop, because your body is in inertia of motion. Is it clear to you? So that is all the examples, or there are other examples rather in the book which you should study, and then you should come out with your writings in the exam. Now coming to answering the questions from inertia of rest and inertia of motion, normally explain the following questions will come, or explain why. In that case, you have to recognize that the body is previously at rest or previously at motion. If the body is previously at rest, straight away you have to write due to inertia of rest. If the body is in motion previously, then you have to use that due to inertia of motion. For writing or recognizing inertia of rest and inertia of motion, you get 1 mark. And for the correct explanation, there is another mark. So normally 2 marks are allotted for such questions which comes from explain the following of inertia of rest and inertia of motion. So you have to recognize which is inertia of rest and which is inertia of motion. Simple thing, if the body is at rest from before, then definitely it will be due to inertia of rest. And if it is moving initially, then it will be due to inertia of motion. I hope it is clear. That will help you in writing the answers also. Okay.